right, now we will do section 4.2 from the book. This is solving systems of equations using substitution. So now, like I mentioned before, solving by graphing is not the most efficient way to solve a system of equations, especially if you have a fractional answer. That would be very, very hard to find, or if you have a hard time graphing carefully. It's a very good way to learn to know what's going on behind the scenes, but in practice, that's not what we use. So here is one of the methods that is used most often. So we'll have substitution in this lecture, and in the next lecture we'll learn elimination. So if we look at this system of equations, we could graph it, but let's do something else. We want to find a point where both these lines cross. So we want to find an x and a y that work in both of those equations. So the x's are the same x and the y's are the same y. So since the y's are the same y, I could take 2x minus 6 and put it in place of y in that first equation. Since y is equal to 2x plus 6, I can substitute 2x plus 6 in place of y in that first equation. So that gives me 2x plus 6 equals negative x plus 3. Now if you look at that, that's just a chapter 2 problem. We know how to solve those. We distribute. We don't have to do that. Nothing to distribute. Combine like terms. No like terms to combine. Move all variables to one side, so we add x to both sides and get 3x plus 6 equals 3. All numbers to the other side, subtract 6 from both sides, get 3x equals negative 3. For the very last step, we'll divide, and we get x equals negative 1. Now, in chapter 2, that would have been my answer. That would have been the end of it. I'd circle it and move on. But now in chapter 4, that's only half of my answer. I have what x equals, but I want to find what y equals. So I'm looking for a point. I'm looking for an x and a y. So I'll take x equals negative 1 and I'll plug it into either equation. It doesn't matter. I'll show you in the problems to come that there is an easier spot to plug it in, but for this particular problem, it doesn't matter. So I just choose the second one, plug negative 1 in place of x. I get y equals negative 2 plus 6, or y equals 4. So my answer is the point negative 1, 4. Negative 1 from the x and 4 from the y. So I have my point. I found where those lines crossed, and I never even had to graph anything. How do I know that I did it right? I have to check it in both equations. Plug it in the first, and it works out great. Plug it in the second, and that works as well. So when we are solving something with substitution, I'll put the steps on the next slide. We want to get one variable by itself, plug it into the other equation, solve, plug that answer in, solve again, and then I'll have my answer that I can check. So here are my steps more explicitly. Solve for one variable. Pay attention to what is easiest to solve for. I'll talk about that as we start this next problem. Next, substitute it into the other equation. Other is capitalized for a very good reason. If you solve for a variable in one of the equations, you have to plug it into the other equation. Solve. That third step, solve, only gives me the answer for one variable, so I have to back substitute. Solve again. That will give me the answer for the second variable. Then I'll check my answer in both equations. So let's say that we have this system of equations right here. 3x plus y equals 1, and 2y equals x plus 9. So there are 4 choices of things that we could solve for. Looking at the first equation, we could solve for x, or we could solve for y. And in the second equation, we could solve for y, or we could solve for x. Let's see which one is the smartest. In the first equation, if I solve for x, what will I have to end up doing? I'll have to end up dividing by 3, and that's going to make fractions. I might have to sometimes, but if I don't have to, I don't want to. How about solving for y? Solving for y would be fine. I'm not going to have to divide. Because y has a coefficient of 1, that y in the first equation would be a good choice. Now look at the second equation. I could solve for y, but I'd have to divide by 2 and make some fractions along the way. It's not going to make things wrong, but it just makes things a little harder. But on the other hand, I could solve for x, and that would be totally fine. Okay, since we saw the y in the first equation, we'll do that first. So if you look up at the top, solve for one variable, I'm just going to say y is equal to 1 minus 3x. Subtract 3x from both sides, and I get y by itself. Now I want you to just kind of hold on to that. We're going to use that y equals 1 minus 3x again in a minute. I substitute that into the other equation. Pay attention to the word other. The way I want you to do this, at least while you're getting used to it, is to write the second equation, but wherever you see a y, leave a big old space. So we have 2y, so 2 times a big old space, equals x plus 9. Do you see that that's exactly the same thing as the second equation? I just have a space where y was. Now, the first step, I had y equals 1 minus 3x. That big old space is where y was, so I'm going to plop 1 minus 3x right there. All right, now I solve. I just have one equation and one variable. So I distribute, get 2 minus 6x equals x plus 9. Variables on one side by subtracting x from each side. Numbers on the other side by subtracting 2 from each side. Get x by itself, divide at the very, very last step, and we get x equals -1. Now I'm not done, I back substitute. Now this is why I told you to hold on to that formula you found in step 1. You can back substitute into either one of the original equations, that's absolutely fine, but the easiest place to plug that back in is what you wrote down for step 1, because you already have y by itself. So let's back substitute in for the y equals 1 minus 3x, we'll put the -1 in for x, solve it, and we get y equals 4. So my answer is the point -1, 4. I'll check that answer by plugging it into both equations, and both equations are true. So that one works. Okay, let me give you another one. Do this one on your own. Your steps are right down at the bottom. Okay, pause the video. All right, now that you've got it done, what variable did you solve for? There isn't a wrong choice, but there is an easiest choice. The easiest variable to solve for is that y in the second equation. So we subtract 10x from both sides, multiply both sides by -1, and we get y equals -1 plus 10x. And you may have written it as 10x minus 1, that's fine. Okay, now I want to substitute that into the other equation. Since I have y by itself, I'm going to leave a big old space where y was in that first equation. So the 5x will stay the same. Minus 3 times the big old space equals -2. Notice how that's exactly the same thing as the other equation. Other equation's important, but I've left a space where y was. So now y equals -1 plus 10x. I plop that in there. And now I'm back to a chapter 2 problem. I distribute. -3 times -1 is 3. 3 times 10x, -3 times 10x is -30x. Now I'll combine like terms, so I have -25x plus 3 equals -2. Next step, subtract 3 from both sides, so I have -25x equals -5. Now how many of you are tempted to write x equals 5? Be careful, it's one of those things where your brain just runs a little bit too fast for its own good. You see 5, you see 25, you know you're dividing, and your brain flips them around. So just be careful, because it is -5 divided by -25, which would give us 1/5, not 5. So just be careful on those. Okay, I have x, how do I find y? I have 3 choices of where to plug it in. I can plug it into either one of the original equations, that won't be wrong, but it's not the easiest place. The easiest place is right there. Y equals -1 plus 10x. So y equals -1 plus 10 times 1/5. 10 times 1/5 is 2. So y is equal to 1. Okay, so my answer would be 1/5 for x and 1 for y. That's my answer. That's what I'd circle. But to check it to make sure I've done it right, I'd plug that 1/5 into both of the original equations. And that is solving by substitution.